So this video is going to be about the Bronsted Lowry definition of acids and bases. And according to the Bronsted Lowry definition, we can think of bases as being substances that accept hydrogen ions, and acids are substances that donate hydrogen ions. And when you think about what happens when you stick an acid or base in water, if we follow the rule that bases will accept hydrogens from water and acids will donate hydrogens to water, we will find that bases are substances that will increase the amount of hydroxide ions in solution, and acids will increase the amount of hydrogen ions in solutions. Okay, so we're going to take a look at how that happens. We've got 4 examples up here. The first 2 are acids. And I've had some questions from people about how do I recognize if something's an acid or a base. The thing that you will recognize with acids is acids tend to, if you look at the chemical formula, they tend to start with a hydrogen. So notice my 2 acids up here are HBr, H2CO3. They both have an H at the beginning of a formula, so that's a way to spot an acid. And I want to say, okay, what happens when I put HBr in water? So I'm going to say HBr plus H2O. And since HBr is an acid, that means that it is going to donate hydrogens to water. Okay, so it's going to donate a H plus ion to my water molecule. So at the end, I'm going to be left with my HBr is going to turn into just plain old Br, and this is going to be a negative ion because I started with something neutral and I lost a positive, so what's left behind is now negative. H2O starts out with 2 H's and is neutral. After it gains an H+, now it's going to have 3 H's, so now it's H3O instead of H2O, and it's got a positive charge. Make sure you pay attention to charge when you're writing these out. Whenever you move a hydrogen ion, you're not only moving a hydrogen atom, but you're also moving a positive charge along with it. So second example, H2CO3, that's carbonic acid. When I put it in water, it is acids donate hydrogens, so it is going to donate an H plus ion to water. So that means it's going to go from being H2CO3 to just HCO3. And it has a negative charge now, because it was neutral and it lost something positive, so now it's negative. Water, H2O, becomes H3O with a plus charge. And what's important to recognize in these types of equations, that when we're talking about H plus ions, in water, when you have an H plus, I'll write this as aqueous, when you have an H plus ion in water, it will stick to water molecules, so it creates this H3O plus ion, which we call hydronium. So you will see these symbols used interchangeably. So you basically can think of as an H plus ion and an H3O plus ion as basically being the same thing. This is what an H plus ion looks like when it's in water. So we can see that acids follow a rule in that they're increasing the hydrogen ion concentration, because whenever you see H3O plus, just think of that as being H plus ions floating around in water. Alright, my second example is bases. And the 2 most common examples you will see of bases are nitrogen-containing molecules tend to be bases, like ammonia, which is NH3, and anions can also be bases, so things with negative charges. Those are your 2 most common examples of bases. And a base is something that's going to accept hydrogen ions. So when I put a base in water, like this first one, methylamine is what that one is called, it is going to take a hydrogen from water. So it starts out as being CnH5, it will end up as being CnH6. And now it's going to have a positive charge because that hydrogen ion carried a positive charge with it. H2O now just becomes HO, otherwise known as OH, and it now has a negative charge. Because my water starts out at neutral, it loses something positive, so what's left behind must be negative. Here's another example. This is the phosphate ion. It will also act as a base if you put it in water. So it has a -3 charge to begin with. My base, it's a hydrogen acceptor, so it's going to take a hydrogen from water. And afterwards, instead of being PO4, it will now be HPO4. And its charge starts out as -3, and I add a 1 to it, so -3 plus 1 gives me -2. So it now has a -2 charge. And water loses a hydrogen and loses that positive charge, so now it becomes OH-. So those are examples of acids and base. You can also have examples of substances that can act as either acids or bases, which I will show you an example of up here. And one common example you might notice is that in those previous cases, water could either accept or donate a hydrogen. And so you might say, well, how can water act as an acid or base if it's neutral? So let's look at what happens with water. So water is neutral. So if our question is, what happens when we stick water in water? Okay, here's H2O. I'm going to stick it to an H2O. These two are the same thing. One of these waters can donate a hydrogen to the other water. So when you do that, what you'll end up with is H3O plus and OH minus. So notice this water is donating a hydrogen, so that makes this water the acid. This water over here is accepting a hydrogen, that makes this water the base. And water, you can basically think of water as being neutral because it's really essentially equal parts acid and base. It can donate a hydrogen and it can accept a hydrogen, and when that happens you'll end up with equal amounts of hydrogen ions and hydroxide ions. And that's what happens when a solution is neutral. That means that the H3O plus concentration equals the OH minus concentration. And that's what happens when you have pure water. So some substances can either donate or accept a hydrogen.